Hello again, engineering fanboys. For some reason, when I was fixing the 3D printer, the video got cut because there's a limit to how much you can record. Because the way my setup is done is like as I record, it sends the video to the server in real time. Like it's streaming it right now. So if it hits the limit of data, then it just cuts the video. I believe that's what's happening. So I was talking and talking as the video, and I didn't realize the video got cut. So this is a continuation of the 3D printed, the 3D print. So PLA material got removed from the head of it. I will show you. So right here, you see here, this is called the here. It's called the head gasket, or at least that's what I call it. It's really, there's a technical term for it, but I don't know. But it's just basically this thing goes like this, X, Y, and a Z direction up and down. And then this thing right here is just the material, just hard plastic. Is called PLA. There's different types of plastics, and they usually melt at 205 Celsius, which is like, I don't even know, like 400 Fahrenheit or something. This is a 3D printer from China, so they use what's called imperial systems, which is called mmgs, millimeters, grams, or seconds. It's like a unit of measurements or something. In SolidWorks, you can determine the unit of measurement by looking at the corner here, and then you click here. You see here you have. I don't know if the camera could get the focus. The hell is it? Oh, I don't even know. It's not showing here, but there's like a corner here. Okay, here now now it could show. Okay, right here, right here. So it's right here. You see mmgs, that's millimeters, grams, seconds, and then the other one is mks, meter, kilogram, second. This one's mks, meter, kilogram, second, and then the other one is cgs, which is centimeter, gram, second, and ips, which is the United States. This one for the United States uses inches, pounds, and seconds. So United States uses inches, pounds, seconds. The rest of the world uses imperial system, grams, millimeters, and stuff like that. So because this 3D printer comes from another country, they use that unit of measurement. Anyways, enough rambling, and let's get to the next part of the print. So you turn it on. You see that? Uh, Very cool. And this, you're supposed to store your PLA material in um, this is called PLA. See, PLA, literally PLA material. Uh, PLA, there you go, right there. It's just poly something something. I don't even know, PLA material. What does that stand for? Let's look at this. PLA material is polylactic acid. Poly Polylactic acid, PLA, is a thermoplastic polyester plastic material made from renewable plant-based materials like corn. The boiling point is 227 Celsius. Now we don't really get to the boiling point because obviously we don't want this thing to boil. But right before the boiling point, you get what's called a phase change transition. A phase change transition means that you're changing from a solid to a liquid. The third phase change would be gas, but we're not getting there. It's just like a water is a liquid, and then it freezes, becomes a solid, and then it evaporates into the atmosphere, back to the clouds. Similarly, but because we want to prototype, we need the solids to stay solid, so we keep it at 205 Celsius for this. So after that, you go to prepare and you click on temperature and you click on the material that you're aiming for. See, right here on the screen, I don't know if this is, yeah, so it has PLA, ABS, PETC, and TPU. So for my particular 3D printer, I can only pick any of those four plastics. Those are all just types of plastics. But 3D printing is insane. Like they're 3D printing bridges, houses. It's like a lot of crazy stuff they're doing. The Chinese are really good engineers. You know, they have incredible 3D printing technology. That's why it's shocking that we don't have this technology in the United States. We have to bring it from other countries. So H1B1 visa. Yeah, weird. So then, once it has reached the desired temperature, actually it has not reached the desired temperature because as you can see here, you have like a fraction or something, a slash 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 slash. So you have 205 or 205. That's good. 49, 50. So you just gotta play the waiting game until it reaches the desired temperature. Just heating up like so. Just wait, be patient, and eventually you should be able to print something. So for the sake of brevity, I'm just going to print out like a little boat. Yeah, there's a boat. Usually, people that want to determine the speed of a 3D print, they print something that's is called a benchy. A benchy is like a little boat, BENCHIE, where the time it takes for the thing to print, it tells you the speed that it can print, basically. So now let's look at it. We'll see 62, 60, 58, 60. So and then you want to work on the distance from this to this. You want to give it some tension and bring it back. So put it like that. All right. So you see this. Now we feed it in here with the little click wheel here. It's a little click wheel here. We feed it. Beautiful. So this is actually pretty good. So you see, I was able to feed it in here in the head, so it has tension and it's snug in place really nicely. And then you can see the bottom of it. Actually, the bottom of it, it's already melting at the bottom. it's really hard to tell, but actually here it is. Uh, okay, here it is. Here it is. See, this is melted PLA. So it gets, it's called a phase change. Similarly to how like water has different phases, like solid, liquid, gas. It's similar with this. You're turning a solid into a technically a liquid for the time that it feeds through the head of the 3D printer. I, if I'm losing you completely, audience, don't feel bad. This is confusing as hell. It should be confusing because it is confusing, but it's not confusing later. Once you get some experience, get the hang of it, it's not confusing anymore. So you see, it's still coming out. Uh, so we got more that's coming out. So it starts right here, comes here, you get the shape that you desire, and bam. Okay, so uh, I think that's good for today. We're gonna leave it at that. Just the feed. So now it's ready for the next part of it. But because I want to make it as simple as possible, I'm gonna break it down into a lot of different sections. So for today, that is good, you know. And I'm trying to keep the videos kind of short, so that's good.